Can you hear me? Law of conservation of mass. Did you get this one? Zinedine. Okay, let me continue then. It says law of constant composition. When elements combine to form a certain compound, they always react in the same ratio, so that the compound always has the same chemical formula. All right. Law of constant composition. This law is also known as the law of constant proportions. So how do you state it? You're going to state the law states that the ratio of elements in a certain compound is always the same. Right? Can you hear me?
Yeah.
Okay. It means that no matter how a compound is made, the number of atoms of each element in the compound is always the same. It is possible for more than one compound to be produced when elements combine. E.g., you've got when hydrogen and oxygen combine, they can form water. So the ratio will be 2 hydrogens is to 1 oxygen. They can also form hydrogen peroxide where there are 2 hydrogens and 2 oxygens. So the ratio, when you simplify, that becomes 1:1. Are you following?
Yeah.
Right, so that depends on the condition. So this is the law of constant composition. It means in a molecule, in a certain compound, the ratio is always fixed. It's always the same for that particular molecule. Clear? So water will always 2:1. If that is the ratio of hydrogen to oxygen. If it goes to 1:1, then it's no longer water. It becomes another substance, which will be your hydrogen peroxide. Clear?
Yeah.
Right. Then there was activity 8, where you had to answer these questions here. Explain what is meant by the term conservation of mass in a chemical reaction. So simply here, the total mass of reactants is going to be equal to the total mass of the product. Clear?
Yeah.
Right? Explain why the number of atoms is conserved during a chemical reaction, but not the number of molecules. So in a chemical reaction, there's going to be rearrangement of molecules, right? To form new substances, so the number of molecules are not going to be the same. Clear? Right, then the next one, in a chemical reaction, 2 molecules of hydrogen react with 1 molecule of oxygen to form 2 molecules of water. By using relative atomic masses, show that mass is conserved. On the memo, I didn't do the memo for this, but you will see the calculations on the memo, just like the top one that I've done. Clear?
Yeah.
Are you following?
Yes.
Okay, right. Then number 4. Right, on number 4, it says give the fixed ratio of the atoms of each element in each of the following. So you're given potassium nitrate. What is the fixed ratio of the atoms of each element here? What would be the answer for A? Someone? For A. Yeah?
113.
Right, so it's 1:1:3. So 1 potassium, 1 nitrogen, 3 oxygens. Clear?
Yeah.
Right, then we go to B. For sodium sulfate, what's the ratio? What's the ratio there? The ratio is going to be 2:1:4. Is that clear?
Yeah.
Okay. Then we move on to the next one. We go to the next one. It's carbon and carbon tetrafluoride. The ratio is 1:4. 1:4. Clear?
Yes.
Right, then the next one you've got potassium oxide there. It's going to be 1:1. So it's 2:2, but you have to simplify the ratio so it becomes 1:1.
1:1.
Right.
Yes,
Then number 5 is the
okay.
one that I explained last time. It's nice for you to see it on the memo. So you check this one on the memo. Is that fine?
Yeah.
Yes, sir.
Okay. Then we move on to the next part here, which is the last part, which is representing chemical change. Right. So what we have, just balancing equations and writing those particular equations. So then we're going to have a look
She's
at
disturbing me.
chemical equations. You have revision of chemical formulae. This is what we did earlier on in the year, where we look at the crisscrossing, writing the names of chemicals. So revision of chemical formulae, revising the writing of chemical formulae from names and vice versa. All right. There's a baby making noise here. Let me check. Let me just mute all for now. Okay. Okay, so let's continue here. We have got revising the writing of chemical formulae from names and vice versa. Please note the need to balance charges in ionics. So this is the crisscross that we did earlier on in the year. Write down the chemical formula for each of the following compounds. So you've got potassium permanganate. So potassium is K plus, and manganate becomes MnO4 minus. So when you write it down, it becomes, the ratio is 1:1, 1 positive, 1 negative. So it's going to be KMnO4. So the permanent ion has a charge of -1 and potassium +1. So the answer is KMnO4. Next one, we've got write down the correct chemical formula for the following compounds. You've got copper oxide. So your copper, right? Your copper in this case is 2:1, and oxygen, we know it's -2. So copper is going to be +1. So the ratio is 1:2. In terms of charges, copper is going to be plus, oxygen is going to be 2 minus. So you need 2 positive. So that's why Cu there, it's going to be 2, because each one brings a positive. So your answer becomes copper oxide. All right. Then translation, translating reaction equations from words into symbols. More often than not, chemical reactions between substances are expressed in words before they are written in symbols. It is important to write the correct chemical formula for each substance described in words. All right. Remember to write down the phases. So in a question, they're going to give you the phase of the substance. Then you need to write it below the chemical symbol. Right, so you're going to use G for gases, and you're going to use L for liquids. You're going to use S for solids, right? Then you're going to use AQ for aqueous. Aqueous means in solution with water, right? There's something else. They're going to be the delta symbol there, which is like a triangle. If it's written on a reaction, it means heat is added. So it means that's an endothermic reaction where heat must be added. We have got endothermic reaction and exothermic reaction. Exothermic reaction, it's a reaction where we have heat being added to a system. Exo, heat is being released. An example here, with the example number 2, the sentence will be given. In this example, we have got iron reacts with sulfur to form iron sulfide. So the word equation becomes iron plus sulfur to give us iron sulfide. You go to your symbols, you're going to have iron, which is Fe. In this case, it will be a solid, and sulfur is also a solid, right? So iron plus sulfur, they're going to form iron sulfide, which is also be a solid. So you'll be given the states, then you have to include them. Clear? Another example would be ammonia reacts with oxygen to give ammonia reacts with oxygen to form nitrogen monoxide and water. All right, so what are you going to have? You're going to have ammonia plus oxygen as your reactants, and nitrogen monoxide and water as your product. So you've got ammonia, which will be a gas, right? And oxygen, which is also a gas, to give you nitrogen monoxide, which will be a gas. And the water, it will depend here. Maybe the water will be vapor, so it will be a gas, or it will be a liquid. So you write L or G depending. Right, then balancing reaction equations. When balancing
Sir.
reaction equations, there are few steps that or hints that you follow. First, write down the correct chemical formulae. If your chemical formula is not right, then your answer is going to be wrong. So the chemical formula for the substance must be correct. Right? In order to balance the equation, ensure that the number of atoms of each element on the reactant side is equal to the number on the product side. So you have to check and add. Right? To bring this about, the only thing to do is to place coefficients in front of the chemical formulae. Don't put them as a subscript, only put them as a coefficient. Do not put numbers in the middle of chemical formula. So you only put them as coefficients. Right? Once the correct chemical formula for a substance has been written, it may not be changed when trying to balance the equation. The number that is put in front of a chemical formula for balancing applies to every element in the chemical formula. Right, so for example, you've got H2O. If I put 3 H2O, it means there are 3 times 2 hydrogens, then 3 times 1 oxygens. All right, okay. Next one, it is useful to balance elements other than hydrogen and oxygen first, then balance hydrogen and if necessary, finally oxygen. Right, another example that we have here, magnesium oxide powder reacts with dilute nitric acid to form aqueous magnesium nitrate and water. Write down the balance equation for the reaction. So you're going to have your magnesium oxide, which is a solid. Then you've got your nitric acid, aqueous, to give you magnesium nitrate, aqueous, to give you water, which will be a liquid. Right? There's one magnesium on the reactant side and one on the right-hand side. So you have to balance now. So you're going to be checking magnesium 1, 1 on the product side. You check your oxygen. Okay, and maybe nitrogen, you go for nitrogen. Here we have 1, and this side you've got 2. Because here the number outside the bracket is going to multiply the nitrogen by 2. So there are 2. So nitrogen here is going to be 1. Right? Then you move on. So nitrogen is not balanced, right? Nitrogen is not balanced. So you need to add a 2 by the HNO3. So you're going to put a 2 here, right? Then you're going to have something like this. You've got your 2 by the nitric acid, right? Then after that, you check your hydrogens. The hydrogen here is going to be 2, and this side is also 2. So hydrogen is balanced. Then you go for oxygen. Oxygen, here you've got 1, and here you've got 2 times 3, which is 6. So 6 plus 1 makes it 7, right? Then you come to the product side, you've got 2 times 3 by the magnesium nitrate. It's 6 plus 1 by the water, which gives you 7. So the equation is now balanced. Clear? Right? So magnesium and nitrogen are balanced, hydrogen, they are balanced, and oxygen is balanced. Clear? Hello?
Sir.
Yeah.
Yes. Okay. Right. We move on to the next part, another example again, balancing chemical equations. In our bodies, sugar, right, which is C6H12O6, reacts with oxygen we breathe. We breathe in to produce carbon dioxide, water, and energy. Write the balance equation for this reaction. So you're going to have your sugar. You have to write reactants is your sugar plus your oxygen. Your product is going to be carbon dioxide plus water. So you write them using chemical symbols. You've got your C6H12O6, that's your sugar, plus oxygen to give you carbon dioxide and water. Then checking now the balancing here, let's count the atoms. Carbon, you've got 6. This side, you've got 1. Hydrogen, you've got 12. And this side, you've got 2, not balanced. Carbon, not balanced. Hydrogen, not balanced. Oxygen, you've got 6 plus 2, which is 8. And this side, you've got 3. So they are not balanced. Right. So it is easier to start with carbon as it only appears once on each side. Right. So if we have got 6 on the left, it means we need a 6 on the right. So we're going to put a 6 by the CO2 here. So we're going to have a 6. So carbon is balanced, right? Then we check again, carbon is 6, and this side is 6. And the hydrogen is 12. Hydrogen here is still 2. Oxygen is 6 plus 2, 8. And oxygen here is going to be 6 plus 2, which is the 12 plus 1, which makes it 13. So it's not balancing, right? So we move on, change the coefficients again to try to balance the equation, right? We have 10 minutes left. Change the coefficient to balance it again. So what are we going to do? We're going to add a 6 on the water, right? Because hydrogen, you have got 12. So we put a 6 on the hydrogen. So 6 times 2 makes it 12, which balances the hydrogens, right? The carbon are balancing. Hydrogen is now balancing. What is left is the oxygen. Oxygen, we've got 6 plus 2, 8. And here we've got 6 times 2, 12. 12 plus 6 makes it 18. So oxygen is not balancing. On one side, we have got 8. And on the other side, we have got 18. So what are we going to do? Now we just need to balance the oxygen atoms. So we're going to put a 6 on the oxygen on the reactants. So it's going to be 6 times 2, which makes it 12. Then 12 plus 6 on the sugar. Then we're going to have 18. Then on the right-hand side, you've got 6 times 2 by the carbon dioxide, which is 12, plus the 6 on the water, which is 18. Then everything is balanced. Clear?
Yes.
Right, then circle diagrams. Sometimes you might be requested to draw circle diagrams. Right, so that will be the application of the models of molecules that we spoke about. So you can do that. Circle diagrams can be used to make the understanding of balancing reaction easier. So here there is an example here. Consider the reaction between hydrogen gas, nitrogen gas to form ammonia gas. Balance the equation and represent the reaction by means of circle diagrams. So here we've got your hydrogen plus nitrogen to give you NH3. Hydrogen is 2, here is 3. Nitrogen 2, nitrogen 1. So it's not balanced. How do you balance it? You're going to have to put 3 by the hydrogen to make them 6, right? Then 2 by the ammonia to make it 6 as well. 2 times 3 makes it 6. And here we've got 3 times 2, 6. Then by putting the 2 here, we've changed the number of nitrogen. There are 2, and the nitrogen here is 2, so it's balanced. Now you can do your circles or your circle diagram. So hydrogen, it's a diatomic, so you need 3 pairs of these circles here. So you're going to have 2, 4, 6, which is 3 times 2 to make it 6. Nitrogen is a diatomic, so 2 dark circles which are bonded together there to give you ammonia. Ammonia, the formula is NH3. So you have ammonia bonded to 3 other circles here, which is representing hydrogen. How many? All in all, we're supposed to have 2. This is wrong here. It's not supposed to be 4. Clear? These are the 2 are not supposed to be here. Is that understood?
Yeah.
Right. So that final product is not right then. Number of atoms, we can check. It's writing here. Okay, hydrogen, if you calculate the mass, it's going to be 2 times 1, which is going to be 2. But because there are 3, we multiply by 3, it gives us 6. Nitrogen, it's 14 times 2 to give you 28. We add all of them, 6 plus 28 gives us 34. So the mass of reactants is 34 grams. You go to the product, you've got your ammonia there. Ammonia is supposed to be 14, 14 for nitrogen, and 3 for hydrogen. So 14 plus 3 gives us 17. 17 times 2, 34. Your total there becomes 34. You check the mass for reactants, 34. The mass for products also 34. You check the 2, they are balanced. So mass of reactants is equal to the mass of the product. Is that clear?
Yes.
Right,
Sure.
so basically that's what you have. Then I gave you this work here for you to write the chemical formulae. Is that clear?
Yeah. Yes.
Right. We have got about 5 minutes left. Should I go over this or we go over? I've got another past paper that I have here. This one here, just to check. But I'm gonna give it to you for you guys to do this as a consolidation activity. I'll send a memo to exercise 8 today. Then after that, you guys, you do the consolidation, then we are done. We've got about 5 minutes remaining. Before I start with this, I just wanted to we discuss before we are cut out of this meeting here. When next can we have the lesson?
Anytime.
Monday or tomorrow?
Maybe
Please
tomorrow.
talk. Huh?
Monday.
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 Okay.
Monday.
We'll have it
Tomorrow,
Monday,
sir.
same time. I'm not sure what the minister is going to say because I had some rumors saying teachers maybe might go to school on Monday. So if I'm at school, we're having a meeting, I might have to postpone it. Do you guys, do you have a WhatsApp group?
Yes. No.
Yes, sir.
You have a WhatsApp group?
Oh,
We don't.
Huh?
no.
We do. We
For all the
do.
classes, for
For all
both
the
the
classes or
classes.
one class?
One class.
One class.
Which one
Tomorrow,
is that?
sir.
It's for both.
Why?
There's
10
two,
Y.
there's two groups,
10Y.
10Y and 10X. There's two different groups.
Tomorrow,
Okay.
sir.
Who's the admin there? Please, I need just the number to, so that if there's anything, I send it to the admin, then he cascades the information. Who's the admin or anyone?
Joshua.
Joshua's not the admin.
Huh?
Who's Edmund?
Isn't Devua the admin?
Please, Devo, can I have your number so that I can send something if I need to communicate urgently? Your number? Devo,
He's not here.
he's not here. Okay, anyone, Oratile, do you have, can I have your number? Joshua?
Sorry,
Oratile?
I'll send you a message.
You send a message, okay. Oratile, also you can send me, or anyone, or Zinedine, or someone there, please send me your number so that at least I can have 1 or 2 numbers, just in case the other one is number is off. No?
Yes.
Yes,
Okay, all right, thank you. Then let's look at this, question number 5. This one came from November 2018, all right? So it says study the physical and chemical processes below and answer the questions that follow. So you're given water, solid to water, gas. With calcium carbonate, to give you carbon oxide solid plus carbon dioxide. You have iron plus oxygen to give you iron 3 oxide. Then define the term physical change. We say the physical change is a reaction in which no new substances are formed. Then 5.2, write down the letter of the process that represents the following, a physical change. So you're gonna check on these two, on these 3 equations, X, Y, Z, which one is not changing its substance? X, Y, Z, which one?
X.
It's X, correct? So we have water. Water is just changing from ice to vapor,
Yes.
right? So that one, the substance is not changing. So that would be the answer. 5.2.2, the decomposition reaction. Which one is the decomposition reaction here?
Why?
Why? We're starting with 1 and we're ending up with 2. So that's a decomposition reaction, right? The other one here, Z, becomes synthesis because we're starting with 2, ending up with 1. Right, next one. Give the name of the physical change stated in question 5.2.1. Right? What physical change is taking place here?
Solid to gas.
Solid to gas.
Solid to gas. What is it?
Evaporation.
Sublimation.
Huh?
Sublimation.
Evaporation.
Evaporation is from liquid to gas, not from solid to gas.
Sublimation.
Sublimation. That one is sublimation. Clear? Right. So that one is sublimation. Correct. Let's go to the next one. State 2 properties of a reaction that indicate that a chemical change has taken place. Right. We spoke about that last time. I think we spoke about that. We said a change in temperature, a change in color,
yeah.
formation of a precipitate, the release of a gas. Clear?
Yes.
Right. Okay. My time is up, unfortunately. Guys, let's meet on Monday.
Yes,
All right.
sir.
If I'm gonna change the settings of the meeting, I'm gonna send them. I will ask Joshua to send them on the WhatsApp group, or I will email you guys so that you use the new logging in details so that we can have more time. Is that clear?
Yes.
Yes,
All
sir.
right. You guys enjoy the rest of your day. Let's meet on Monday.
Yes.
Thank you,
Bye.
sir.
Okay. I will
Sir,
send
thank
the
you.
consolidation exercise